Hello everyone, and welcome to 7th grade Math Module 1, Proportional Relationships. In this video, we're looking at Lesson 7, Unit Rate as the Constant of Proportionality. Our learning goal is to make sure we can calculate the constant of proportionality and use it to solve problems. This will help us to master Standard 7 RPA2, recognize and represent proportional relationships between quantities, and 7 EEB4, use variables to represent quantities in a real-world or mathematical problem and construct simple equations and inequalities to solve problems by reasoning about the quantities. We've already seen that relationships are proportional if all ratios are the same in simplest form or if the unit rates are equivalent. We've calculated this constant of proportionality, or set of equivalent unit rates, by taking our y and dividing it by our x. Once we have a constant of proportionality, we can use it to find missing values in a proportion, using either multiplication or division. We've even used our fact family triangle to help us keep straight when we need to multiply values with our constant of proportionality and when we need to divide. Today we are applying what we know about unit rate, constant of proportionality, and proportional relationships to solve problems. In example 1, we're looking at the National Forest deer population. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? So, if this deer population is not constant in all areas of the forest, that could indicate some sort of problem. And this is something that actual conservationists look at. So let's help them solve their problem. First, we need to find our population density of deer per square mile. If you couldn't tell by our keyword per, this is going to be a unit rate. And if the unit rate is the same for all of the pairs of numbers, this will be a proportional relationship, making our unit rate a constant of proportionality. So I can see by deer per square mile that our deer is going to be our y value and the square miles will be our x value. So we can divide the number of deer by the number of square miles. So for our first pair of numbers, that's 144 deer divided by 16 square miles, and we get 9 as our unit rate. For our second pair of numbers, 117 deer divided by 13 square miles, we get 9 again. For 216 deer divided by those 24 square miles, yet again we get 9 as our unit rate. So our unit rate of deer per 1 square mile is 9. So if we were to write that out as a constant of proportionality using our units, we would say that is 9 deer per square mile. Remember, when we're writing our units for unit rates and constants of proportionality, we want to make sure we say the value of the first y units per, and then the second value, the x units. So what does this mean, this 9 here? Well, it means that for every square mile of forest, there are 9 deer. So just explaining that right out in a sentence and thinking about what it means in real life. Now that we have our unit rate of 9 deer per square mile, we can use it to help us solve some problems. The first problem we're going to use it to help us solve is we're going to determine how many deer there are for every 207 square miles. As we have already established, our square miles are going to be represented by x, and our deer are going to be represented by y. So we can use our fact family triangle here and see that to find y, we would do k times x. So when I take my unit rate of 9 times the 207 square miles, we get that there's 1,863 deer. Now, instead of solving for a y value, let's try solving for an x value. We're going to use our unit rate now to determine the number of square miles in which we'd find 486 deer. So again, in this case, we're missing our x value, and we have our y value of 486. So looking at my fact family triangle here, I see that when I'm looking for my x value, I can divide my y value by my k value. So I can do that 486 divided by 9 and get 54 square miles. We could also solve this problem algebraically using the same equation from letter C. If we start with y equals k times x, we can replace the k with our unit rate of 9 and the y with the amount of deer, 486. This leaves us with a one-step equation. Since the 9 is being multiplied with our missing x value, we can do the inverse of division to isolate our variable x, which ends up doing that same 486 divided by 9. And we still get that there are 54 square miles. What does this video make you wonder about calculating your constant of proportionality or unit rate and using it to help you solve problems? Write your questions down so you don't forget them. Then you can find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.